identifying and applying properties of similar triangles, our warm-up. By the way, everyone's looking up here? Without headphones, please. Okay. Like we learned the last 2 days, we're doing cross multiplying and dividing, or you can call it butterfly method. So x times 4 is 4x. And then 5 times 10, don't forget the equals. 5 times 10 is what? 50. So 4x equals 50. Let's solve for x. The coefficient 4 we need to get rid of. We are going to divide. So we will put divided by 4 on both sides. And we get 50 over 4 is, and if you're not sure, calculator can help you. You can hit 50 divided by 4, control enter, 12.5. Okay. That works out. Now, we got some notes to do. If you hadn't finished the assignments from the last 2 days, we'll have some time tomorrow. Real quick, because we're about to do brand new notes. And then you might have some time at the end of today. We'll see. Okay, so our notes look like this. Now, y'all remember when we did congruent figures? Okay, congruent. Wait, while we're doing the notes. Congruent figures, we said were same size, same shape. Does that sound familiar? They're exact same size, exact same shape. Okay, but for similar, something's different about it. So if you're just looking at the pictures, you can see the outside numbers. These are side links. This 5 and this 7.5, they don't match up, right? 4, 6, those don't match up. 2 and 3, those don't match up. But look at the inside. The angle, the degree angles are the same. 25 degrees matches, 41 degrees matches, and so on. So here's what we got to know for similar. Y'all ready? Let's write this down. Similar figures are the same. Now, is that the same shape or the same size? What do you think? Same shape. Okay, they're the exact same triangle, but it's either enlarged, okay, or dilated, larger, or shrunk, smaller, okay? So it's not the same size, okay? Same shape, not, let's underline the not the same size, cool? If y'all remember when we did congruent triangles, we said you could not use SSA, the booty word, and you couldn't use AAA, the batteries word, okay? Well, why not? Because AAA, if all the angles are the same, that doesn't mean the triangles are the exact same, right? Look, these angles match, but the sides don't, okay? So there's a reason why we didn't use AAA when we did triangle congruence, because AAA works for similarity, cool? Now, before we proceed, let's figure out the missing angle here, because I see something missing, makes me want to fill it in. Do y'all remember from last year, last semester, okay, which was last year, what do we do to get a missing angle inside of a triangle? How many do they add up to? How many degrees? 180. Hopefully you remember that. You got to know that like forever, okay? So how do I figure out the missing one? What should I do with the 2 I know? Let's add those up. Very good. 41 plus 25 is 66. And let's take that away from 180. And I get 114. I'm going to fill that in for angle B. And I'm going to put that in for angle E because those have matching angles. Okay. Now, let's fill this in. Similarity is what we're talking about today. The 2 triangles above are similar triangles. The way that we say this is in math notation. This in math notation is with the following similarity statement, okay? Now, what we're going to be using is this little symbol right here, okay? It's called a tilde or a tilde or tilde or something. But I affectionately call it a squiggle, okay? Squiggle. If you have a squiggle between two triangles in a statement, that means you're saying they are similar, not congruent, right? You remember congruent had the little equals underneath it, right? Like this is congruent, but just a squiggle is similar. Same shape, different size. Cool. So notice this statement. Triangle ABC is similar to triangle DEF. So let's write this out phonetically, so to speak. We read this as triangle ABC is similar to triangle DEF. That's how you say that statement. That's how you pronounce the math statement. Now, I'm putting these side by side because we kind of need to fill in these angles, okay? So, and didn't we say these were 114, right? Okay. Now, y'all could do this on your own, but what does angle A match with? What other angle? Angle D. B matches with angle E. Angle C matches what? Angle F. Do you see I'm just looking at the picture? Those degree measures match up. Okay, that's easy. And then the second column here, what is the degree number, the value, the measurement? So angle A and D are 25 degrees. Angle B and E are 114 degrees. C and F are 41 degrees. Cool. So that's your angles. Your angles are equal. Your angles are same. They're congruent. Okay. But let's talk about these sides now. Okay. AB. How long is segment AB? What number is between A and B? 4, right? DE, between D and E, is 6. So in that tiny little fraction bar, you're going to write it as a fraction. 4 over 6 right here. All right. And what's BC over EF? BC, EF. What am I going to write? Okay, 2 over 3. And then AC over DF, 5 over 7.5. Okay, now, we made fractions out of the corresponding sides. Now, the question is, what does that equal? So I'm going to zoom in here. 4 over 6. Now, if I put this into my calculator, 4 divided by 6, it just gives me another fraction. Okay, so 4 over 6 reduces to 2 over 3. That's cool. Or, if I hit Control-Enter, I get 0.6 repeating. Okay, so we're going to put 0.67. We're going to round it to the 100. Okay, so everyone with me? Heads up, not looking at your phone. Okay, now the next one is already 2/3. So obviously, it doesn't reduce because 2/3 is the most reduced. Or 0.67 again. Okay. Now the last one, 5 over 7.5. Let's try that. 5 divided by 7.5. I get the same decimal. So guess what? It's going to be the same fraction. There's not really a way to go backwards on that, but you know 0.667 is going to be the same as 2/3, right? Okay, now each of these proportions gives me, what do you notice about these three things? They're all the same, right? They're all 2/3. Cool. So in similarity, when I make fractions out of those sides, they should give me the same exact number. That's called being proportional. proportionality. Now, off to the right, go ahead and fill this in. The number that they all equal is called a scale factor between the two triangles, okay? If you've ever seen Zoolander, which is a funny Ben Stiller movie, okay? He jokingly, or he's kind of like a dumb model, right? Like a fashion model. And these guys bring him a little, they're like, hey, we want to build this center for kids who can't read well. And so they make a little, what the building would look like, you know? And he looks at it and he's like, how can people learn? It's so small. What is it, a center for ants? That's the joke. He doesn't understand that it's just a proportional little version of the building they're going to make later, okay? So in architecture and all this other stuff, you make little proportional similar things, and then you make the big thing later. Okay, that's just a little, maybe a funny reference. I should have shown you the clip. I want to see a clip? Thank you. Now we're going to get people right there on the second page. Our conclusions about angles and sides. All right, where two triangles are similar, their angles are what? Always the same. Always, it's actually put congruent. Whenever we have same size, same shape of angles, also we put congruent. So the angles are always congruent. However, their sides, what's that word we've been using the last couple of days? It starts with a P. Proportional. 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 It's an ugly O. There you go. All right. So the sides are proportional. That means if you set up the sides as a ratio, they're always going to be equal to the same number like we just learned. Okay? Now, we got to keep moving here. We want to write a similarity statement down here. I want you to underline this. This is very important. Last 9 weeks and today. Order matters. Order matters. Okay. So 49 and 33, let's add them up. 49 plus 33 gives me 82. And I subtract that from 180 and I get 98. So my missing angle on the first triangle is 98 degrees. Now, notice, if I have 49 and 98 here, and I have 49 and 98 here, then that third angle is going to be the same. This will have to be 33, okay? So you can tell, once we did a little bit of math, both triangles have all the same angles, and we're on the second page of the note. Okay, so here we go. Now, let's go ahead and answer this. Let's see what we know. It says, which of the following is not a correct similarity statement for the triangles below? So everybody, I said it, I'll say it again. Order matters, okay? Things have to match up. So you tell me, does this first statement match up correctly? A, B, C, D, E, F. What do you think? Okay, well, A, the first letter is 98 degrees, and then D is 49 degrees. Those don't match, right? Cross that one out. That one is doesn't match. What about CAB and FDE? No? Well, C is 33 degrees, the first letter, F is 98. Again, they don't match perfectly. You can't make a statement if it's not in the right order because order matters. Now, last one. Is CBA similar to FDE? What do you think? Okay, C is 33, but F is not. F is 98. So they're actually all three wrong. Let's make our own statement. We'll start with triangle ABC. Now y'all tell me, what does ABC match with perfectly? Okay, FDE. So triangle ABC, put the squiggle, that means similar to triangle FDE. That is a good similarity statement. Cool. Now, here's where we're going to use what we did the last 2 days on these triangles. I want you to notice in this picture, and I'm going to ask you to do this every time, there's a connection between the corresponding sides. Do you see that 3 corresponds with 4.5? So there's an arrow there. 5 corresponds with x, so there's an arrow there. So here's what you do. You make fractions out of those and set them equal, just like our warm-ups the last 3 days. Cool? Everyone with me? Especially if you're on a phone. Check it out. 3 goes to 4.5. I'm going to put 3 over 4.5. Equals, and then 5 goes to x, 5 over x. Cool. I made 2 fractions, and they're equal. And this is very important. They have to be consistent. If you go from left to right on your fraction, you have to go left to right on your other fraction. Okay, they have to match. Could you solve that? Like the warm-up from the last 2 days and today. Let's do that real quick. 3 times x is 3x. 5 times 4.5, if I don't know, I go to my calculator and I type it in, equals 22.5. My last step to get rid of a coefficient is to divide. So I divide by 3, divide by 3. And then 22.5 divided by 3 is 7.5. Cool? So do you see how what we've been doing with proportions goes with similar triangles? Cool? Okay, let's do it again. This time, you're going to connect them. So y'all tell me, what does 3 correspond to? What am I going to connect? Okay. So like you said, 7 goes to x plus 2. I'm going to actually draw the connection. 7 goes to x plus 2, and then 3 goes to 6. Does everyone see how I'm actually connecting them? I like this. It's just a good way to see. That is a fraction, and then that is the other fraction. So let's write this up. 7 over x plus 2. I like to put it in parentheses. And then the other one, 3 over 6. Don't forget the equals between them. 3 over 6. And now, once again, cross, multiply, and divide. Now this one's a little bit, maybe a little bit more complicated, but we definitely went over that on Monday. So let's go over it now. 7 times 6 is 42. You might need to write small because I know we might run out of room here. On the other side, 3 times x plus 2. Here's how you write it. 3 parentheses x plus 2. And then, what do we do with that 3 to the parentheses? Distribution. You distribute the 3, which means you're going to multiply 3 times x, 3 times 2. So 3 times x is 3x. 3 times 2 is 6. Bring down 42. And now we want to solve for x. So on the right-hand side, we have a 3x plus 6. I need to get rid of the loner first. If you don't remember, the loner is the number by itself on the side with x. So let's get rid of that positive 6 by doing the opposite. What's the opposite of positive 6? Minus 6. Minus 6. The opposites cancel out, and now I have 42 minus 6, which is 36, equals 3x. And your last step, you want to write this down? You got a pencil? Okay. And then your last step to get rid of that coefficient 3 is to divide by 3. Okay? So 36 over 3 gives you 12. Sometimes you have these slightly more complicated problems, and you got to do it this way, okay? If you've got that down, you can flip it to the next page. Okay. Now, on this one, look right here. There is no x, right? If there's no x, it's not like the ones we just did. So this one, we have all the sides. If you know all the sides, let's think about this. It says, are they similar? Okay. Well, how do I know they're similar? From the sides. I need to see if all three pairs of sides are proportional, if they make the same fraction, like we did on the front side of the note. Okay, so let's think about this. What has happened to this triangle to get to this triangle? Tilted, it's kind of been rotated, maybe it makes it a little bit smaller. Okay, so whenever you're thinking about this, you have to think it's been a little bit rotated. Cool? So I like to show that with a little rotation symbol. It's been rotated. All right, so you tell me, what does 9 correspond with on the other triangle? And it's not 6, because remember, it's been rotated. So 9 goes to 3. Kind of weird, because it's been rotated. 12 goes with 4. 18 goes with 6. Again, you kind of got to think, when you rotate it, where does it match up? So all three of those connections are going to be fractions, and then we're going to see if they're all equal or proportional. Sign on to the left. So the first one, 9 and 3, let's make a fraction, 9 over 3. The second one, let's make a fraction, 12 and 4, so 12 over 4. And the last one, 18 to 6, 18 over 6. Now here's the question. What do these three fractions equal? So 9 over 3 is 3. 12 over 4 is also 3. What do you think 18 over 6 is going to be? Always check every one of them, because one of them, if one of them's not right, then they're not similar. Okay, but in this case, they're all 3. Since every corresponding pair divides to make the same number, they're proportional. Okay, so are they similar? Yes. The sides are proportional. So we need to make a statement. Okay, write a similarity statement. Triangle ABC, and the similar sign, remember, it's a squiggle. Squiggle, triangle. Now you tell me, what does A, B, and C match in order on the other triangle? Okay, so it's been rotated. A goes to E, B goes to D, C goes to F, so it's EDF. All right, so you see how that works. If they ask you, is it similar, you got to show three fractions that are the same, that's proportional, okay? All right, so these next ones we're going to kind of breeze through. What do you think happened on number 2 to this triangle? It's a different orientation, right? So this actually has been rotated. This is another rotation. Cool. So what does 11 match up with? X or 35? 35. So 11 goes to 35. And then 4 goes to X, right? You with me? Put the phones away. So all you got to do is set up those fractions. 11 goes to 35, so that's a fraction, 11 over 35 from left to right. 4 goes to X from left to right, so 4 over X is my other fraction. You put an equal sign between them, and that's good. So the hardest part is seeing what changed about the triangle and make sure you're matching everything up right. All right, move your head up. So let's go ahead and cross multiply and divide this, okay? We're going to move a little bit faster because I know y'all know how to do this by now, or I hope, okay? So 11 times X is 11X equals 4 times 35 is 140. And then to get rid of that coefficient 11, I get rid of that 11 by dividing by 11. 140 over 11 is, control enter, 12.7273. 12.73 when I round that. Okay. We got 2 more examples I got to show you, okay? So stick with me, and then we'll be done faster. On number 3. Now, how many triangles do you see on number 3? How many triangles do you see on number 3? 1. So there's one big one, and within it, there's a smaller one, right? So a smaller triangle within a bigger triangle, they're overlapping. This one can be tricky. So again, here's a tricky one. Don't get tricked. I'm going to show you how to not get tricked. I'm going to outline the small one. Okay? What are the two sides on the small one that we know? 7 and 9. Cool? Now, again, I'm going to see how smart y'all are. What's the bottom of the big triangle? 17.5. That's easy. Here's where people goof up. I want y'all to be goofy, right? On the right side, how long is this? Boom! First time. That's great. Now, here's the deal. If these were two numbers, wouldn't you add them up? But here's what some people do. They say, oh, it's just x. No. Or they say 9x. No, that's multiplying. It's 9 plus x. It's literally 9 plus x in parentheses. I know that's kind of weird, but that's right. Very good. So here's what I want you to do. I'd like to redraw the big one off to the side. Now the bottom we know is 17.5. That doesn't change. The right-hand side, the 9 and the x, is going to be 9 plus x. Cool? Okay, now let's do what we just did on the last triangles, and let's go ahead and connect corresponding sides. So what does 7 correspond with? 7 goes to 17.5, right? And then 9 goes to 9 plus x, okay? Let me tell you, because people, most people when they do this, they say, oh, 9 goes to x. The whole side is 9 plus x, cool? All right, now we can set it up, cross multiply and divide, cool? Again, I'm going to set this up, 7 over 17.5. Don't forget the equals. 9 over 9 plus x in parentheses. And could you cross multiply and divide that? Okay? Since we've done it like numerous times together, I'm going to do this a little bit faster. So 7 times 9 plus x equals 9 times 17.5, which is 157.5. I need to distribute the 7. 7 times 9 is 63. 7 times x is 7x. I need to get rid of the loner on the left side, which is 63 minus 63 minus 63. Gives me 94.5. And then divide by 7 to get rid of that coefficient. Then I get 13.5. Okay. Again, that was a little bit faster because we've done these. One more to do, and we'll be done with these notes. So flip it over to number 4. Does anyone still need this? Number 4. How many triangles do you see? 2, right? Little triangle within a big triangle. So once again, let's outline the little triangle. And I know the little triangle has two sides, 6 and 4, right? But the big triangle is what we need. So I'm going to redraw the big triangle. What is the left side of the big triangle? What is this whole length right here? I take these two numbers, add them up. 9 plus 6, 15, right? Let's write that down. And then on the right-hand side, what do I do with 4 and x? Just like last time, add them up. 4 plus x is, parentheses, 4 plus x. And now you can connect your corresponding sides. 6 goes to 15. 4 goes to 4 plus x. Can you set those two fractions up equal, cross multiply and divide? 6 over 15 equals 4 over 4 plus x. Again, cross multiply, so 15 times 4 is 60. 6 times 4 plus x. I write it next to each other. And now I'm going to distribute 6 times 4, 6 times x. 6 times 4 is 24. 6 times x is 6x. Get rid of my loner 24 by subtracting. 36 equals 6x. And then divide by 6. And x equals 6. Cool. There's some proportion practice here, but I'd hold off on that. Don't worry about 5 through 13 right now. What I do want you to worry about is Monday and Tuesday's assignments. If you weren't here Monday or Tuesday, or you lost them, or you need them, they're in the blue bin with the date under geometry, the very first section. And if you have them and you're not done with them yet, you got a little bit of time to try to knock those out, okay? Hold on to these notes till tomorrow. You're going to use them to do some similarity practice, all right? Here we go.